Hi. This lesson is a combo lesson because I did not record 2.4a yesterday, and so what I need to do is just do a little recap. So I'm going to ask you to press pause on your video so that you can just catch up on the notes, because I'm not going to go over every example in this video right now. So I want to briefly explain the basics and then talk about adding and subtracting. The basics of imaginary numbers are: this is a number that can't be defined. It is the square root of -1. And whenever that would happen, like say in quadratic formula, if I got a negative number underneath the square root, I can't define that. I don't know where that is on a number line. It's not a real number. It's a fake number, so we call it imaginary. And we use these imaginary numbers only when there's negative signs underneath the square root. So I to the first power is the square root of -1. I squared is I times I, right? So it's the square root of -1 times the square root of -1, which is the same thing twice. The square root of -1 squared, right? Well, what we know about squared and square roots is that they're opposite inverse operations of each other and they cancel each other out. So you end up getting a -1 for I squared. And I to the third is just a negative sign with I, negative I. In adding and subtracting, you're going to be combining like terms. So the i's go together. The whole numbers go together. You really have to pay attention to what's in between the parentheses, because if there's a subtraction sign in between the parentheses, that means that I'm going to have to make sure that both numbers after, like this 6 becomes negative, and this -7 would become actually a +7. So you really have to be careful with the signs. So I want you to press pause on the video right now and copy down all of these notes from 1 through 7. Okay, so I'm assuming you got those 7 copied down. I now want to go on to the next lesson. So let's do multiplying. One big thing that I just said to all the kids sitting in here right now is that I squared equals -1. So do you all have the notes in front of you? Class, not the video people. Class. White paper. Okay. So, and it's not back there? Oh, can you get out a piece of lined paper and write these in? If I stop the video, I have to start all over again. I'm so sorry. Oh. Okay. Thank you for being flexible. All right. So, starting off, we're going to solve for square roots. I just said earlier in the video that like a square root and a squared cancel each other out. So if I had like the square root of 7 squared, the answer would just be 7. So what's going to happen is in these examples, this is straight down. This is already solved for you. So I start off with something like x squared equals 25. Square root both sides, and then you're going to get plus or minus 5. And maybe you're wondering, why is it plus or minus? Because -5 times -5 equals positive 25. So there's the negative version. And +5 times +5 also equals positive 25. So that's the positive version. So it's 2 answers, plus or minus. The answer would then be plus or minus 5. On x squared equals -81, I square root both sides. And this is going to be -1 times 81. -1 is the I. Square root of 81 is the 9. So that's how it becomes plus or minus 9i. I want to practice 4 down here. We already did this one. X squared equals negative 81. So, first step, square root both sides. X squared square rooted is just X. This becomes negative 1 times 81. I just did this one. X equals plus or minus 9I. Okay, 625. That squared is microscopic, I know, but it's there. Please square root both sides. All right. X equals, does anyone know what the square root of 625 is? It's a big number.
Like 25?
It is 25. Out comes the 25, and the negative 1 is the I. X equals plus or minus 25I. Number 3, square root BS, both sides, plus or minus 12I. Easy?
Yes.
54 is marginally easy. Square root both sides. It is not a perfect square. It's, break it down. 4, 9, 16. What goes into 54? 9 and 6. Ready? Negative 1 times 9 times 6. Out comes, oh, well, first of all, hold on. X equals plus or minus. Ready? 9 is the 3. Negative 1 is the I. Okay. That's simplifying. If I have an x squared and I need to just solve for x, the next four down here at the bottom are going to be foiling. So x, I squared equals negative 1. And I'm foiling. First, outer, inner, last, like we did when we were factoring. It's a binomial times a binomial. First, outer, inner, last, F-O-I-L. Okay? All right, here we go. First, 6 times 5, 30. Outer, that's these like 6 and the 3i, the outer numbers. 6 times 3i. What do you guys want to say that 6 times 3i is? 18i. Great. Inner, negative 4i times 5, negative 20i. Last, negative 4i times positive 3i. Negative 12i times I. Here's where it becomes my I squared. You're going to replace I squared with negative 1. So let's go through and combine like terms and whatnot. 30 minus 2i minus 12 instead of I squared. Can you please put a negative 1 right next to it? Negative 12 times negative 1. This becomes positive 12, right? 30 minus 2i plus 12. Anything I could put together? Any combining like terms I can do? Yeah. Yeah. So that's going to be 42 minus 2i. Remember, standard form is the number first and then like a plus sign or something and then the I term. The number has more significance than an I. An I is imaginary. It doesn't have a value, really. So this number sign would come first because it's like got a number that you could put on a number line. It has a value. And an I is like, well, we don't even know what its value. We don't know anything about this I. Remember, the only reason i's exist is because if there happens to be a negative underneath the square root. It's not often that you see imaginary numbers in math. But you will see some as we do like graphing later on, but don't worry too much about that right now. So we're just foiling. So I'm going to do 2 of them with you, and I'm going to have you do 2 on your own. So I'm going to do first, outer, inner, last. 2i times 2i, 4i squared. Outer, 2i times negative 3. What is that? Just yell it out. Negative 6i. Inner, negative 3 times 2i. New person. Woo, painful. Negative 3 times 2i. 6i. We're multiplying. Last, negative 3 times negative 3 plus 9. You need to do I squared and make it negative 1. Minus 12i. Put those together. The 6 and the 6 can go together and make negative 12. All right. Negative 4 and 9 can go together. Oh, it's cut off. Negative 4 and 9. 5 minus 12i is the final answer. Number 2 is called the difference of 2 squares because it's the exact same numbers, but just plus and minus. Difference of 2 squares. And this is the last one I'll end with. 5 times 5. 5 times 6i plus 30i. Negative 6i plus 5. Negative 30i. Negative 6i times positive 6i. Negative 36i squared. These 2 cancel and make 0. Positive 30 and negative 30. That makes nothing. 25 minus 36 times negative 1. Replace the I squared with negative 1, please. Okay. Then 25 plus 36, yeah? And I get what? 61. Okay. So 3 and 4 are going to be group work, table work with the people that you're sitting with.